What is up, everybody? Got another video here for you. This is statistics, and this is random variables and probability distributions. So let's go ahead and get started. So it says a quantitative variable x is a random variable if the value that x takes on in a given experiment or observation is a chance or random outcome. All right, so if we do an experiment, we need to have a random outcome. All right, and we have two random variables here. We have a discrete random variable and a continuous random variable. A discrete random variable can take on only a finite number of values or a countable number of values, and a continuous random variable can take on any of the countless number of values in a line interval. All right, so let's use this example to kind of give you an idea the difference between discrete and continuous random variables. So they want us to determine if the following random variables are discrete or continuous. All right, so let's not do these in order. Let's start with number 2. Okay, so it says count the number of bad checks written in a day at a bank. All right, so how many bad checks can be written? Well, it can be 1 bad check, 2 bad checks, 3 bad checks, 4, 5, 6, 7, and so on. Okay, see, we can count those. All right, so this would be discrete. That would be a discrete random variable. Now, let's come up here and it says measure the time it takes a student selected at random to take a test. The time it takes, that should be a S there on the end of take. So measure the time it takes a student selected at random to take a test. Well, is that discrete or continuous? Well, how long can it take them? Can we count that? Let's see. It could take them 30 minutes. It could take them 40 minutes. But it could take them 30 minutes and 2 seconds. 30 minutes and 2.3 seconds. 30 minutes and 2.067 seconds. So we can't count that. It can take on an infinite number of numbers in a certain time interval. Okay, so this would be continuous. All right. What about this one? Measure the amount of gasoline needed to drive your car 300 miles. Well, what would that be? Well, how many gallons of gas do you use to drive your car 300 miles? Well, you could use 10 gallons. You could use 10.5, 10.32, 10.05 gallons. Okay, that takes on an infinite. That's an infinite number, right? You can take on any number within a certain, within however many gallons of gas your car holds. So this would be continuous also. And then pick a random variable of 40 registered voters in a district and find the number who voted in the last election. So of the 40 people, how many voted in the last election? Well, it's going to be 1 or 2 or 3 or 4. It's not going to be 4.05, is it? You can't have 0.05 of a person vote. Okay, so you can see that is discrete. All right, so hopefully that gives you an idea of the difference between discrete and continuous. Discrete, you're able to count it. It's going to be a 1, a 2, a 3, a 4, or something like that. But continuous, it can take on any value, decimals and all that good stuff. All right, now let's look at this. A probability distribution is an assignment of probabilities to each distinct value of a discrete random variable or to each interval of values of a continuous random variable. Features of the probability distribution of a discrete random variable. The probability distribution has a probability assigned to each distinct value of the random variable, and the sum of all the assigned probabilities must be 1. Okay, so basically each distinct value of the random variable, you're going to have a probability assigned to it between 0 and 1. And then if you take all the values and you add them up, all those probabilities, they have to equal 1. Okay, so let's look at this example, and I think this will help you understand. I'm sorry, I'm yawning. It'll help you understand better what a probability, a discrete probability distribution is for a discrete random variable. So it says a doctor developed a test to measure boredom tolerance. He administered it to a group of 20,000 adults between the ages of 25 and 35. The possible scores were 0, 1, 2, 3, 4, 5, and 6. So you can make a 0, a 1, a 2, a 3, a 4, a 5, or a 6, with 6 indicating the highest tolerance for boredom. The test results for this group are shown in the table. So I've got two tables here. This is the only way I could figure out how to do it up and split it. This is a table and this is a separate table. Okay, this part right here, that's supposed to be a gap there, but I couldn't figure out how to hide those lines. All right, so of the 20,000 people, the 20,000 adults that administered the test, 1,400 scored a 0, 2,600 scored a 1, and so on. Okay, so this is the information they give us. These are the test results, the test scores for the 20,000 subjects. Now over here we have a probability distribution of the scores on boredom tolerance test. Now, more than likely what's going to happen is this column here is not going to be given to you. I went ahead and filled it out. Okay, but I'm going to show you how we get these values here. So you've got the scores 0 through 6. So you put the scores 0 through 6 here. Okay, and basically what will happen is they may give you this data here, and they'll say create a probability distribution table. And so what you would do is you would do this, put 0 through 6, and then we have to calculate these columns here. And I'm going to show you how we get that. Okay, so how do we get these different probabilities here? Well, for a score of 0, 1,400 subjects scored 1,400, and that's 1,400 out of how many? Out of 20,000. So that would be the 1,400 out of 20,000, and that's how you would get the 0.07. And then for this one, you would do 2,600 divided by 20,000. For the 0.18, you would do 3,600 divided by 20,000. And for the ones that made a 3 to get the 0.3 or the 30%, that would be 6,000 divided by 20,000. And then for this one it would be 4,400 divided by, hopefully you're getting the idea of what I'm doing. And then for this one it would be 1,600 divided by 20,000. And then for this one it would be 400 divided by 20,000. And you would just punch all this into your calculator, and that would give you each of these values here. So that's how you would create a probability distribution table. Okay, and then we can also look at a graph of this thing. So if we were looking at the graph, we can see that the largest value is 0.3. So if we looked at that, then we would have, let's see, We're going to have a little break here. All right, so let's do 0.3 here. And then I guess we can do 0.2, and then we can do 0.1 right here. And for here, we would have 0, 1, 2, 3, 4, 5, and 6. And so you can see for a score of 0, we've got 0.07. So that's going to go almost up to the 0.1. Okay, 0.07 is a little below 0.1. And then at 1, a test score of 1, we've got 0.13. So that's going to go a little above the 1. And then for a score of 2, 0.18. So that's going to go up to about right there. And then for 3, we've got 0.3. So that's going to go all the way up to here. Okay, we're basically have a histogram here. Whoop, I hit something, didn't I? Come on, get off the screen. Let me see. Okay, anyway. I don't know, I hit something with my hand. I got a little box popped up over here. And then we've got 0.22, which that's going to be right here. That's at 4, test score of 4, and then 0.08. So that's going to be a little higher than the 0.07. And then we got 0.02, which would be about right in there. And so that would be your, a graph of the distribution. Now, what if it said find the probability that someone made a 5 or a 6 on the boredom tolerance test? So the probability that they made a 5 or 6 on the test, well, there's a 5, there's a 6. You see that? So remember, that's the probability. That's the probability that they made a 5 plus the probability that they made a 6. And keeping in mind, these are independent events. Remember in the last video, we learned all about that. So for the 0.05, that would be 0.08 plus the probability we made a 6. That would be 0.02, which would be 0.1. All right, so that's the probability that they made a 5 or a 6. Now, the other thing that I want to point out here, another way that we could have gotten this 0.1, yeah, we got it from the table here, but we could have also added up the areas under these bars here. See the area of this, see what's the height of it? The height of it is 0.08, right? And the width is 1. What's 1 times 0.08? 0.08. That's the area of that rectangle. And same thing here, this width is 1. The height is 0.02. 1 times 0.02. So basically, we're adding the area up of these two rectangles here, and that can give us the probability also. All right. So that's probability distribution for a discrete random variable. Now, as far as this class goes, we don't get into continuous random variables, but they wanted to show you the difference between the two. The continuous random variables, that's in a little more advanced statistics class. Calculus will start getting involved in that. So, but this is an introductory statistics class. All right, so let's look at this next part. All right, so it says the mean and standard deviation of a discrete population probability distribution are found by using these formulas. So how do we find the mean and standard deviation of these things if we have a probability distribution? Well, the mean, now this little symbol here, this means to sum. This sigma, that means to sum x times p of x. So mu is equal to the sum of x times p of x. Mu is called the expected value of x. And sigma, the standard deviation, is the square root of the sum of x minus mu squared times p of x. and sigma is called the standard deviation of x. And x is the value of a random variable, p of x is the probability, and the sum is taken for all the values of the random variable. And note, mu is the population mean and sigma is the underlying population standard deviation, because the sum is taken over all values of the random variable. So hopefully you remember earlier in your statistics class you talked about population and sample, a population and a sample mean, or population and sample standard deviation. So remember, a sample, that's saying like you've got you're at a university and you want to find the average weight of the students at the university. Well, you're not going to go ask every student. You may go pick out 1,000 students, okay, and ask them their weights and then base the average on those 1,000. That would be a sample. But if you use every student, that's a population, and that's what we're doing here. We're using all the values of the random variable, so it's the population. All right. So let's look at this next example. I'm going to show you an easy way to calculate this stuff. All right. All right. So the example, are we influenced by ads on TV? National Infomercial Marketing Association determined the number of times buyers of a product had watched a TV infomercial before purchasing the product. The results are shown below. All right, so number of times buyers saw the infomercial, 1, 2, 3, 4, or 5 times. And the percentage of buyers was 27%, 31%, 18%, 9%, 15%. Or instead of looking at these as percentages, you can look at it as 0.27, 0.31, 0.18, 0.09, 0.15, right? You remember how you can 0.27, 0.31, 0.18, 0.09, and 0.15. We can convert the percentages to decimals. All right, now let's look at what we've got to find. We've got to find the mean, which is equal to the sum of x times p of x, and we've got to find the standard deviation, which is the sum of x minus mu squared times p of x. That's all I did here, is I just wrote down both of my formulas. Oh, and I wrote this one down wrong. I forgot the sum of x minus mu squared times p of x and the square root of that. All right. So I just wrote this formula down and this formula down so we can see what we need to get. All right, so the best way to do this is to make a table. All right, so I want to make my x column, which that's going to be 1, 2, 3, 4, and 5. Okay, these are my x values. That's the number of times the buyer saw the infomercials. And then I've got my p of x column. That's my probabilities. So that's 0.27, 0.31, 0.18, 0.09, and 0.15. All right. Now, all that information there is given. Okay. Now, let's see what I need. What do I need? Let's just look at the mean first. I need x times p of x. So I'm going to make a column called x times p of x. And so I do 1 times 0.27 is 0.27. I do 2 times 0.31 is 0.62. And then I do 3 times 0.18. that is 0.54. 4 times 0.09 is 0.36. And 5 times 0.15 is 0.75. All right. Now, we can actually find the mean. So the mean is just the mean is the sum of x times p of x. So it's just the sum of this column. 0.27 plus 0.62 plus 0.54 plus 0.36 plus 0.75, and that is equal to 2.54. There's your mean. Okay, that's your mean. All right, now what do I need? Well, I need x minus mu squared. So let's do x minus mu squared. All right. So let's just write the first one out. Okay, let's write the first one out. So if I want to find it for the random variable 1, if I want to find it for 1, that's going to be, what did it say? X, which is 1, minus mu, which is 2.54, and then all of that squared. And then when I punch that into my calculator, I get 2.372. All right. And then if I want to find the next one, I've got x, which is 2 minus the mean, which is 2.54, and then all of that squared. So if I punch that into my calculator, I get 0.292. And then the same thing. And look, all you're doing, you see the 2? We're going to do it for 3. So it's 3 minus the mean squared. And that is going to be 0.212. And then I want to do it for 4. So the 3 will be replaced with 4. So 4 minus that squared is 2.132. And then I need it for when x is 5. So I put a x minus the mean, 5 minus 2.54, and then square that. That's going to be 6.052. All right. So that's how you get this column. Okay. That's how you get that column. Now, what do we need? Well, what do we have to sum? Well, we've got this and we've got p of x. So now I need to multiply this value and this value together, and then I sum them up and take the square root. And so if I do x minus mu squared times p of x, so I've got 2.372 times 0.27, and that is going to be 0.64. And then if I do 0.292 times 0.31, that's going to be 0.091. And then if I do 0.212 times 0.18, that's 0.038. And then this times this, that's going to be 0.192. And then I do this. Oh, wait a minute. What did I? Okay, I hope I was showing this wrong. Okay. I think I'm losing my mind. I hope that I don't know what I showed you in the video, but I hope I showed you this column times this one, this column times this one, this one times this one, this one times this one times the 0.09, and then this one times this one, and that would give us 0.908. Okay. I can't remember. I don't know if I pointed to this column instead of this one. If I pointed to this column, don't pay attention to that. It's this column. See, it's p of x times the x minus mu squared. So p of x times x minus mu squared. All right. Just get caught up in all the excitement and make mistakes. So sigma would equal the square root, and then we would just sum all those up. 0.091 plus 0.038 plus 0.192 plus 0.908. And I believe all my values are correct, And so the standard deviation would be, let's see, I'll have to punch that into my calculator. Let me see. Yeah, so that's going to be the square root of 1.869. And so the standard deviation would be the square root of that, which is 1.367. So there's your standard deviation. All right. So that's how you find the mean and standard deviation of a probability distribution. All right. So they give you the distribution, and then you got to find the mean and standard deviation. All right. So hopefully that helped. All right. So this is the last part here. All right. So let's look at this. So it says, let x be a random variable with mean, mu, and standard deviation sigma. Then the linear function L equals a plus b of x has mean, variance, and standard deviation as follows. All right, so they're giving us a linear function. So how do we find the mean and standard deviation and the variance? Well, the mean is just a plus b times mu. Sigma squared, or the variance, is b squared times sigma squared. And then the standard deviation is, of course, the square root of that, the square root of b squared times sigma squared. And that's sigma sub L. So that's the standard deviation of the linear function. But you'll be given mu and sigma. And notice here they have the absolute value of b times sigma. Well, that's just showing you that b has to be positive. It needs to be positive there. All right. And then if we have let x1 and x2 be independent random variables with respective means, mu1 and mu2, and variances, sigma sub 1 squared and sigma sub 2 squared, for the linear combination, w is equal to a times x sub 1 plus b times x sub 2, the mean, variance, and standard deviation are as follows. And it's these formulas here. I'm not going to read through them. You can look at them and see, but it's just the mean for w is a times mu sub 1 plus b times mu sub 2, and so on. Okay, and the variance is a squared times sigma sub 1 squared plus b squared times sigma sub 2 squared. And then, of course, the standard deviation is just the square root of that variance there. All right, so let's look at some examples. And before I do that, I'm going to get my cat out of my lap. She jumped up in my lap while I was making the video. She won't leave me alone when I'm at my computer. All right. So here's our example. Let x1 and x2 be independent random variables with respective means. Mu1 is 75, mu2 is 50, and standard deviation sigma 1, 16, sigma 2 is 9. All right, so let L equal 3 plus 2x. Compute the mean, variance, and standard deviation of L. So if you notice in these examples here, this first example, see, we just have the x, but in all these other ones down here, we've got an x1 and x2. So for the first one, we're up here with these formulas. See, we just got the variable x, but in the other ones, x1 and x2, we're going to be using these formulas, see, with the x1 and x2. All right, so first, let's find the mean of L. All right. So remember, up here, it just says that it's a plus b times mu. And what's a and what's b? Well, in this case, there's a, there's b. A is the constant, B is the number in front of X. And mu, okay, so we've got 3 plus, okay, because we know A is 3 and B is 2. See, A equals 3, B equals 2 for this one. And it's basically A plus B times mu. Now, what's mu? Well, we're doing we've got just the one variable, so we're using the x1, the mu1 for that. And so that's times 75. So you just plug the 75 in and you get 153. And then if we want to find the variance, well, what's the variance? That's b squared times sigma squared. So b is 2, so that's going to be 2 squared times sigma squared. So we're going to use the sigma 1 because we just got the one variable. And that's going to be times 16 squared. And so that's going to be 1024. And then the standard deviation is the square root of that. And that is going to be, what is that? Is that 32? Let me see. Let me make sure. Is it 32 squared? Yep, 32. And so there's your mean, variance, and standard deviation. So you can see it's pretty easy. You just need identify A and B. All you got to do. And then, for the variance and standard deviation, and then for mu, you're just plugging in the mean for mu. So you're plugging in the mean right here. All right, so what about these next ones? So we've got let W equal x1 plus x2, compute the mean, variance, and standard deviation of W. Okay, so it's just, well, what's the formula? It's A times mu1 plus B times mu2. Okay, A times mu1 plus B times mu2. And so you can see here A is equal to 1 and B is equal to 1. That's the numbers in front of x1 and x2. See that? AX1, BX2. So we plug in A and B, they're each 1. And then we've got our means, mu1 and mu2. Well, there's mu1, there's mu2. And so we have the mean is equal to what? 1 times, 75 plus 1 times 50. See, I just plugged in A and B and mu1 and mu2. And that is 125. All right. And now what about the standard deviation? Not the standard deviation, but the variance. So the variance, what is that? That's A squared sigma 1 squared plus B2 sigma 2 squared. All right, so I've got A squared times sigma 1 squared, so that's times 16 squared. So that's times 16 squared plus B squared, so that's 1 squared, times sigma 2 squared. Well, what's sigma 2? That's 9. So times 9 squared. And that is equal to 337. All right. And then the standard deviation is just the square root of that. This is the square root of the variance. So that's 18.36. And there's your answer right there. Okay. All right. So what about this one? And I think what I'm going to do here is I'm going to... There we go. Give myself some more room. All right, so let's continue on with part C. And what I did, I just went up here and I copied these formulas. I just copied the formulas and pasted them down there so we didn't have to keep scrolling back up and down. So we got the formulas right here. All right, so let's compute the mean. so the mean, all right, so let's identify A and B. So in this problem, A is equal to 1, B is equal to -1. Okay, that's the number in front of x1 is 1, and the number in front of x2 is -1. That's your A and B. And so the mean is just 1 times mu1. And so let's see, mu1 is 75. So mu1 is 75, mu2 is 50, I believe. Yeah, and the standard deviations are 16 and 9. Let's just write them down here. It's 16 and 9, so we don't have to keep going back up. All right, so that's A times mu1 times 75 plus B, so that's -1 times mu2, which is 50, and that is equal to 25. How about that? And then the variance is A squared, so that's 1 squared times sigma 1 squared, so times 16 squared, plus B squared, so that's -1 squared, times sigma 2 squared, so times 9 squared, and that is going to be 337. And so that's the variance, and then the standard deviation is, of course, is just the square root of that, and that is going to be 18.36. All right, so you can see this is not that bad. All right, so let's copy this and paste it down here. Let me get this up there. All right. So let's paste this. And then let's see if we can, whoop, let me do this. See if we can bring this on down. Look at that. I'm getting good with this stuff. All right, so let's find the mean. All right, so we got 3x1 minus 2x2. So let's go ahead and identify A and B. So A is equal to 3 and B is equal to -2. All right, so we'll just plug it in. So we got A times mu1, so that's times 75, plus B, which is -2 times mu2, that's 50, so times 50. And that is going to give us 125 is the mean. And then the variance is A squared, so that's 3 squared times sigma 1 squared, plus B squared, which is -2 squared, times sigma 2 squared, so times 9 squared. And that ends up giving us 2,628. And then the standard deviation is the square root of that. And that is going to be 51.26. And there's your standard deviation. And guess what? I know you're going to be sad hearing this, but that's the end of the video. All right. So hopefully all that made sense. I hope it helped. Appreciate you watching. Check out my other videos. Give me a like, share, subscribe, comment. And I will see y'all in the next one. Later.